It's just incredible how fast AI is moving, isn't it?
Yeah.
And lately, the big jumps, well, they're not just about text anymore. We're really seeing AI take a huge leap in understanding images, sounds, even video. It's going beyond just, recognizing that's a cat to really getting the whole picture of the complex situations.
That's absolutely right. We're in this really interesting phase where different AI fields are merging. And this leads us to what the research calls large multimodal reasoning models, or LMRMs. Our main source for this deep dive is this fantastic survey paper that gives a really comprehensive look at this whole area.
Okay, LMRMs, let's break that down a bit. So instead of just like one type of input, these AI systems are built to handle multiple things at once: text, images, audio, and use all that together to figure out complex stuff. The survey puts it as aiming for, what, comprehensive perception?
Perception, precise understanding, and deep reasoning.
Right, so really seeing everything that's there, getting what it means, and then reasoning about the why and the what's next.
Exactly. And, to get the full story, we're not just looking at the survey. We've also pulled in a study on AI and robotics, fascinating connection there, and a report on AI in education.
Oh, interesting.
Plus, we'll touch on some of the newest models making waves, like OpenAI's o3 and o4-mini, and also DeepSeek's R1 and V3, based on some recent articles.
Okay, quite a mix of sources. So our mission today is to really unpack what's truly significant about this multimodal reasoning stuff in AI right now. What makes these models such a big deal? And, what are the big roadblocks that researchers are still trying to figure out?
Well, maybe let's start with how we even got here. The survey paper traces this interesting evolution. See, early multimodal systems, they were often modular, kind of siloed.
Modular, meaning like different pieces doing different jobs.
Pretty much. You'd have one bit handling the visuals, another the text, maybe a separate part for the actual reasoning. They didn't always talk to each other that well.
Right, like different specialists who weren't really collaborating.
Exactly. But the big shift recently is towards these unified systems. Often, language is right at the core. These multimodal LLMs, large language models, they're designed to handle all these different data types within one single framework.
Oh, so it's more integrated.
Much more integrated. It allows for this connected, cross-modal understanding. The AI can actually make links between, say, an image and text in a way that's much more like how we humans process the world.
And I think I read about techniques like, was it multimodal chain of thought, MCO, and reinforcement learning playing a role.
Yes, definitely. Those are key.
Helping these models build more complex, sort of step-by-step reasoning chains.
Absolutely. Think of multimodal chain of thought, MCOT, as letting the AI kind of show its work, When it's tackling a complex problem with different data types, it doesn't just spit out an answer. It can outline the steps it took, which makes it more transparent and hopefully more reliable. And the survey really points towards the future with this idea of native large multimodal reasoning models, NLMRMs. The big vision there is for AI that's truly scalable, can handle more data, more complexity, agentic, meaning it can act and interact in adaptive, learning in real-world situations.
Agentic.
Yeah.
Sounds like it has more autonomy. Okay, this is where it gets really practical. What can these things actually do? The survey breaks it down, right? 4 main areas.
That's right. They talk about understanding, generation, reasoning, and planning. Let's maybe take them one by one. So understanding, this covers both visual stuff, like figuring out what's in a picture, and audio stuff, like understanding sounds.
Okay.
And the progress in audio is pretty significant. Models aren't just transcribing speech. They're getting better at understanding a whole range of sounds, the nuances. The survey mentions specific benchmarks, things like voice bench, audio bench, air bench, SDE val. These are designed to really push and test these audio understanding skills. Audio bench, for example, might test if an AI can tell apart different musical instruments or identify sounds in the environment.
Right, so not just what was said, but maybe how it was said.
Right.
Or what else is happening sonically. Got it. What about generation? Sounds like AI creating stuff.
Precisely. Joint multimodal generation is about creating content that actually mixes different modalities. A common example is text to image. You give it a prompt, like a cat wearing a tiny hat, and it generates the picture.
Okay, seen those.
Data sets like ADT20K and Coco Stuff full of labeled images are crucial for training these models to accurately match the text description. And we're also seeing work on generating like interleaved image-text content, weaving pictures and words together coherently. Think maybe creating more dynamic web pages or stories. Datasets like Interleaved and Annaly are used there.
That makes sense. Now, reasoning.
Yeah.
This feels like the absolute core of it all.
It really is. And the survey draws a useful line between general visual reasoning, understanding spatial relationships, cause and effect in a picture, and more domain-specific reasoning.
Domain-specific, like?
Like solving math problems presented visually or interpreting complex charts. There are benchmarks for both. For general visual reasoning, things like Natural Bench, VCR, that's Visual Common Sense Reasoning Test, if the AI can make logical deductions about everyday scenes in images. For the domain-specific side, you have Math Vista, Chart QA. They check if AI can actually understand and work with math or graph data.
And I remember seeing something about omnimodal reasoning. That sounds complex.
Oh, absolutely. Omnimodal is the big challenge. It's about reasoning across many modalities at once: images, audio, text, video, maybe more. Benchmarks like OmniMMI, OmniBench, BabbleBench, they really show how tough this is, even for the best models. You often see performance drop off quite a bit as you add more modalities. The AI has to juggle simultaneously. Yeah, especially when it has to generate the reasoning steps for anything that isn't text. So it might analyze an image okay and understand text okay, but truly linking them, explaining the connection, inferring something deeper using both, that's still a major hurdle.
So like watching a movie clip and understanding the plot by combining the visuals, the dialogue, and the background music cues.
Yeah.
That's way harder than just describing the scene.
Exactly. It's that synthesis that's tricky.
Okay. And the last category was planning. What's multimodal planning about?
Think about GUI navigation. That's a great example. An AI agent that can look at a website or computer screen, understand the buttons, the text fields,
Right.
and then figure out the sequence of clicks and typing needed to do something specific, like booking a flight online or changing a setting in your operating system. Benchmarks like Webarena and Osworld are built to test exactly this kind of planning in interactive digital spaces.
Wow. Okay. So you could just tell it, book me a flight to London next Tuesday.
Yeah.
And it figures out how to navigate the airline's website to actually do it. That's a big step.
Yeah.
So how are they actually achieving this level of reasoning? The survey mentioned different methods.
Right, several key approaches. One big one is multimodal LLMs-based implicit reasoning. The core idea is clever. You take the visual input or audio or whatever isn't text, and you kind of translate or project it into the language model's world, into its text space. This lets the model use the incredibly powerful reasoning skills that these large language models already have built up from learning on vast amounts of text. We see this in models like CLTCAP, Elava, MiniGPT-4, QuinnVL. They all have slightly different ways of aligning the visual and text features so the LLM can process them together.
So you're basically making the image speak the language of the text model so it can reason about it.
That's a great way to put it, yeah. Another important set of techniques comes under externally augmented reasoning. Here, the model gets help from the outside. It can use external tools or resources. Could be using search algorithms to find extra information, maybe accessing knowledge bases to look up facts, or even using specialized smaller models for specific analyses, like analyzing a chart in detail. So the model might see something in an image, realize it needs more context, and use a search tool to find out more about it.
Okay, so it's like giving the AI its own toolkit or letting it phone a friend when it gets stuck. That makes a lot of sense for complex problems.
Yeah.
Now, you also mentioned agentic multimodal reasoning. This sounds like the AI becoming more proactive.
Exactly. Agentic AI is about systems that don't just process information passively. They can adapt their strategies based on feedback they get from their environment. They learn from what happens when they take an action and adjust their next move.
Yeah.
It's not just following a script.
Right.
We're starting to see frameworks for this, like the Model Context Protocol, Agent-to-Agent Protocol, things that help these AI agents connect with tools and interact with external systems more smoothly.
And there have been some impressive demos, haven't there? Like operator interacting with operating systems or Claude computer use manipulating desktops.
Yes, those are great examples. It's like the AI is beginning to operate within the digital world almost like a user would.
Developing a kind of digital agency.
Precisely. And of course you need ways to measure this, so benchmarks like AgentBench, Osworld, Visual Webarena are emerging to evaluate how well these agents can perceive, reason, and act in these interactive settings.
Okay, let's pivot slightly. We also looked at that study on AI and robotics. How does multimodal reasoning fit in there? Seems like a natural fit.
It's absolutely fundamental. AI is revolutionizing robotics, especially in pattern recognition from sensor data and making complex decisions in real time. Robots are essentially embodied agents. Their ability to perceive the world through multiple senses, vision, touch, maybe others, and reason about it is crucial for them to do anything useful.
The study talked about actuators, the robot's muscles and sensors gathering data. AI seems like the brain connecting the two, right? Making sense of sensor input and controlling the actions.
That's a perfect analogy. In factories, AI-driven robots doing welding, painting, assembly, they're achieving levels of accuracy and efficiency that were unthinkable before. We also see them increasingly in logistics, warehouses, and even navigating tricky outdoor environments. Key AI techniques here are things like data-driven learning from experience, and object detection, using convolutional neural networks, allowing them to see and identify things very accurately.
So the robot learns to spot different parts, understands the task, maybe pick up the red box, and adjusts its grip based on what it sees and feels. That's multimodal reasoning in action. Now, another interesting angle was AI in education. The report highlighted a lot of excitement, but also some caution.
Yes, the report makes a strong point. AI models have huge potential in education, but they're not magic bullets. They have limitations. It's really important to understand when and where they might fail or not align with actual educational goals. Personalized learning systems are a good example. They use AI to spot patterns in how a student learns and then suggest specific resources or activities.
Trying to tailor the experience to the individual student. But the report also raised questions about the balance, the dynamic between the AI and the human teacher, right?
Absolutely. Finding that sweet spot is critical. AI could help teachers create more engaging lessons, design better assessment questions that test deeper understanding, not just recall.
And provide faster feedback.
Exactly. More timely, personalized feedback. But there are also concerns. Figure 8 in the report visualized this tension between human and AI decisions. And Figure 9 raised concerns about potential increases in teacher surveillance or issues around student data privacy.
Right, those are serious considerations.
The report also touches on algorithmic discrimination, making sure AI tools don't unfairly disadvantage certain groups of students. Fairness is key. And it really emphasizes the need for research that looks at context. How does this AI tool work for these students in this specific school environment? It's not one size fits all.
That makes total sense. We need to ensure AI in education actually works equitably for everyone. Okay, let's switch back to the cutting-edge models we mentioned. OpenAI's o3 and o4-mini, and DeepSeek's R1 and V3. These seem to be really pushing the envelope.
They really are. The OpenAI models, o3 and particularly o4-mini, show significant gains over previous versions. They're performing better on tough benchmarks for coding, advanced math, science reasoning, and they have stronger multilingual capabilities too.
And I heard about their self-fact-checking and tool use within ChatGPT. That sounds like a big step towards that agentic AI you mentioned.
It is. They can now reportedly use tools for things like browsing the web for current info, running Python PERD for calculations, managing files, even generating images directly as part of solving a problem. And o4-mini is supposed to be particularly strong on visual analysis, even better than o3, and apparently incredibly fast at complex math. Essentially, they're merging the deep reasoning power of the O series with the conversational fluency of the GPT models.
What about the DeepSeek models, R1 and V3?
So DeepSeek's R1 is quite recent. It's specifically tuned for code, logic, and math. A big point about R1 is that it's open source and designed for efficiency. That's attractive for many developers and organizations. V3 came out a bit earlier, late 2024. It's really good with structured data, strong on multilingual tasks, and also benchmarks well in math and reasoning.
It's great to see this kind of competition and different approaches driving innovation. But, despite all this amazing progress, the survey was also clear about the challenges that still remain. Big ones.
Oh, definitely. The road ahead still has bumps. One major challenge is scalable high-fidelity fusion. Basically, how do you effectively blend information from different modalities so the result is more than the sum of its parts, capturing those complex interrelations?
Right, getting the mix just right.
Then there's multimodal hallucinations. This isn't just making stuff up in text, which LLMs can do. It's misinterpreting the relationships between data types, like describing an object in an image that simply isn't there, or completely misunderstanding what a chart is trying to show.
Oof. Yeah, that could lead to really bad decisions if you rely on it without checking. What else? Cross-modal adversarial resilience. Security. We need defenses against attacks that might exploit vulnerabilities across multiple data types, not just text. Then there's reasoning depth. Current models, even the best ones, can struggle with really complex multi-step reasoning that requires deep, abstract understanding. And finally, omnimodal generalization, that challenge we talked about earlier. Getting models to perform well across all sorts of different data types, truly universally, is still really hard.
So yeah, incredible progress, but still a way to go to reach that kind of seamless, human-like multimodal understanding. The survey did point to some exciting future directions, though, didn't it? Absolutely. Lots to look forward to. We'll likely see more simulation-based training using virtual worlds to train AI agents in complex dynamic environments. The idea of personalized agent ecosystems is fascinating. AI companions with long-term memory that learn and adapt with you. Edge multimodal AI, getting these powerful models running efficiently on local devices like phones. That could be huge.
Real-time processing right on your device.
Exactly. Continuous interactive learning is also key, especially for agentic models, letting them learn constantly from real-world interactions and feedback. Imagine an AI learning to use new software just by trying it out and getting feedback, and long context support being able to handle and reason about much longer inputs, like full video files or long, complex documents with mixed text and images. And underpinning all of this is that conceptual push towards those native large multimodal reasoning models, the NLMRMs, aiming for scalable, agentic, adaptive AI for the real world.
It really is a compelling vision for where things might be headed.
It certainly paints an ambitious picture.
Okay, let's try and wrap this up. We've covered a lot of ground. From the core idea of large multimodal reasoning models integrating text, image, audio, to their evolution from modular to unified systems. We talked about their key capabilities, understanding, generation, reasoning, planning, and the benchmarks used to measure them. We saw how AI is impacting robotics and education through this multimodal lens.
And we touched on those state-of-the-art models like O3, o4-mini, R1, and V3, showcasing the rapid progress.
Right. But we also spend time on the significant hurdles that remain: fusion, hallucinations, security, reasoning depth, omnimodal generalization. It's clear there's still lots of work to do.
That sums it up well. And it's worth remembering, like you've hinted at, the impact isn't just robotics or education. Think finance, healthcare, anywhere complex, diverse data needs understanding. These models could play a role.
Absolutely. So maybe here's a final thought for you, the listener, to chew on. As these AI systems get better and better at perceiving and interacting with the world in ways that feel increasingly human-like, what does that mean for us? How might it change the way we learn, the way we work, even just how we interact with technology day to day? And as these omni-models, I like that term some people are using, become more woven into our lives, what are the really deep ethical questions we need to grapple with? It feels like this massive potential balanced against a real need for careful, responsible steps forward.
That's the crucial balance, isn't it? And for anyone whose interest is piqued, we really do encourage you to look up some of the papers and articles we mentioned. This field moves so fast, staying curious is the best approach.